Here are the answers for the day 2 warm-up. Write formulas for compounds made from the given ions. Remember, the key principle is that a compound is neutral. So if a compound is made out of positive and negative charged ions, the positive and negative charges must balance out. Question A, sodium. In order to make the compound, you have to know that sodium makes a positive 1 charged ion. The reason that we know that is sodium is located in group 1. It has 1 valence electron, which can be lost, resulting in a positive 1 charge. Sulfate is SO4 with a negative 2 charge. Sulfate is polyatomic, and so we can get this formula and charge from the page 268 chart. Sodium is positive 1. Sulfate is negative 2. The least common multiple of a positive 1 and a negative 2 is 2. So think about how many sodiums are needed to have a positive 2 and how many sulfates are needed to end up with negative 2. We need to have 2 sodium ions, but only 1 sulfate ion. So you write Na2, that's your 2 sodiums, but then only write SO4 1 time. Question B, tin 2. So that's SN positive 2. Perchlorate. Perchlorate is polyatomic. I know this because of the ending, ATE. Remember that monatomic ions end in "ide." Polyatomic ions typically end in "ate" or "ite." There's a couple exceptions, and they're on the page 268 chart. The symbol is ClO4 negative 1. To create a neutral compound, think about the least common multiple of those charges. Positive 2 and negative 1, the least common multiple is a 2. We want to have 1 of the positive 2 charged tins and 2 of the negatively charged perchlorates. Here's our single tin ion, and here are the 2 chlorates. Notice the use of the parentheses around the ClO4 so that you can then put a subscript of 2 indicating that you have 2 of the ClO4s. Question C, write the names of the compound below. Na is sodium, ClO2 is made out of chlorine and oxygen, therefore it's polyatomic, and you can find its name on the page 268 chart. It is chlorite. So this compound is sodium chlorite. Question D. First we have Pb, that's lead, and then the Br, that's bromide. Lead is one of the metals listed on the page 266 chart that uses Roman numerals to identify the charge on the lead. This lead ion might be lead 2, or it might be lead 4. Here's how you determine that. Figure out the negative charge on the bromide. Bromide is in group 7A, so a single bromide ion has a negative 1 charge. There's a subscript of 2. 2 bromide ions have a total negative charge of negative 2. There is only 1 Pb, and the charge of that Pb must balance negative 2. The Pb must be a positive 2. And now we know what Roman numeral to include in the name. Lead 2 bromide. There's a lot of thinking that we have to do to come up with the name of this. We have to recognize that Pb is going to have a Roman numeral, and then think about how to determine which Roman numeral it is from the page 266 chart. We need to recognize that the Br is monatomic, and so the word is bromide. It's not bromine or bromate or bromite or any other ending. We need to use the negative charge to help us figure out what is the positive charge on the lead to get its Roman numeral. So a lot of steps that all happen in our heads on this. Question E. Here I see Pb again. So I know it's either +2 or +4. In order to figure out which it is, we have to look at the negative charge. So Se, that is the element selenium. When it's an ion, it would be selenide. Selenium is in group 6A. A single ion of selenide has a -2 charge, but the subscript says there are 2 of those, which is a -4 charge total. Compounds are neutral, so there has to be a +4 charge to balance that -4. There is only one Pb ion, so it must be a +4. If this formula had said Pb2, meaning that there were 2 lead ions, then each of them would have been a +2, because having 2 +2s would get us a +4. But that's not the case here. With only a single lead ion, it must be a +4. So the name is lead-4 selenide.